in this type of limit, you cannot just plug in the x. Take a look at the first limit. Do you see that the first rational function, there is a x plus 5 in the denominator. So what happens when you plug in x equals to negative 5? You have a 0 in the denominator. So in this type of limit, which is very popular, you have to simplify the function first before you plug in the x value. Let's do it. So the first problem, we have limit as x approaches to negative 5, x squared minus 25 divided by x plus 5, right? This is a square. Okay, so the x squared minus 25, we can factor that. Limit as x approaches to negative 5, the top becomes x plus 5, x minus 5, so x plus 5, x minus 5, the bottom is x plus 5, so we can do a cancellation, right? So take a look. We have x approaches to negative 5. It looks like the denominator is our biggest enemy, right? Because you plug in, you get a 0. Everything got messed up. But as long as you factor, you can get rid of the denominator. So now the enemy is eliminated. Then you can plug in. So plug in negative 5, you have negative 5 minus 5. That is equals to negative 10. So that is your answer. How about the next problem? Can the function be always simplified? Let's find out. Limit as x approaches to 1, x divided by x minus 1. Can this rational function be simplified? So this is impossible to be simplified, right? So this function cannot be simplified. So we cannot eliminate, so cannot eliminate x minus 1. So as a result, you plug in 1, you have a 1 divided by a 0, right? So the limit does not exist. You can just write DNE or write that the limit does not exist. Usually in calculus, we use DNE for does not exist. All right, the next one is x squared minus x minus 6. Okay, let's do it. So the next one, we have limit as x approaches to negative 2. We have x squared minus x minus 6 divided by x squared plus x minus 2. So if you plug in a negative 2, you have a 4, right? Minus 2, you have a 0 in the denominator. So that's why you have to factor the top and bottom first, cancel our biggest enemy, and then you plug in. Limit as x approaches to negative 2. So factor the top. Can you do it in 2 seconds? So the top, you have what? You have x plus 2 and then x minus 3. So 2 times negative 3 is negative 6. 2 minus 3 is negative 1. And then the bottom, you have x plus 2 and then x minus 1. Okay, what is our enemy? Our enemy is x plus 2. Once you plug in negative 2, you get a 0 in the denominator. But after you factor, we can get rid of the x plus 2, so we are happy. Then you plug in. You have negative 2 minus 3 divided by negative 2 minus 1. So you have a negative 5 divided by negative 3. So you have a 5 over 3 as your final answer. All right, let's move on. So let me just go up like that so you can still see the problem, but you can see the next one. Okay, let's use this color. So we have limit as x approaches to 1, 2x minus 2 divided by x to the third plus x squared minus 2x. So when you plug in a 1, you have a 1 plus 1 minus 2. You have a 0 in the denominator. Therefore, you have to factor the denominator. So x approaches to 1. This one, I would like to, since the last term is not a constant, it's a negative 2x, I will just factor our x. So this is x squared plus x minus 2. The top is, I'm not sure if that is necessary. Let's just do it first. Factor out the 2. You have x minus 1. And then you go ahead to factor the denominator one more time. The top, no change. X and then that's the same as the previous one, so x plus 2 and then x minus 1. All right, so it looks like the minus 1 is our biggest enemy. However, that is just cancel. So now we are safe to plug in 2 divided by 1 and then 1 plus 2. So you have a 2 over 3 as your final answer. All right, and then the next one we have, let me just, let me do this. I'm going to go ahead and then copy this and then bring it down. So I don't need to keep going up and down. So the next one requires you to know factoring the sum of cube and difference of cube. Okay, so let me just make a note right here. So factor a sum, and I should say sum slash difference of cubes. What is this? Let's do a review. So you have a to the third plus b to the third. You are trying to factor this a to the third minus b to the third. For the plus, you have a plus b, and then a square minus ab plus b square. You have to use this in calculus once a while. And then this is a minus b, and then a square plus ab, and then plus b square. The difference is for the plus, you have plus minus. For the minus, you have a minus plus. Okay, so back to our problem. You have limit as x approaches to 2. You have x to the third minus 8, x minus 2. That must be an 8 because 8 is 2 to the third power, right? And then limit as x approaches to 2. All right. We cannot plug in a 2. That is very obvious. Okay, so we have a minus. So that means we follow this. So we start with x minus 2. How do I get the 2? I got 8. 8 is equals to 2 to the third power. And then we have x squared plus ab, which is x times 2. So that is equals to 2x. And then plus b squared, 2 squared is equals to 4. And then I can see that the x minus 2 will be cancelled. And then you plug in a 2, so you have a 2 squared plus 2 times 2 plus 4. So that will be 4. The answer is 12. All right. The last one is pretty interesting. Every time I write an exam or a quiz, I will put the last one in there because I want to test everybody to see if they know the conjugate or not. Okay, moving on to the final problem. So the final problem is you have limit as x approaches to 1, square root of x minus 1 divided by x plus 1. I mean x minus 1. This, you have to use the conjugate. So let me write the conjugate in a different color. So this, you have to use a conjugate. What is the conjugate? The conjugate is, listen, you have to look at where the square root is. So this time the square root is on top, right? So when the square root is on top, you have to write this and then use the opposite sign. And then multiply the same thing on the denominator because this is equals to 1. If you write a 1 in the denominator, that is super wrong because you multiply the given function to another function, then you change the whole problem. So this is called conjugate. You learn this before taking calculus. And then the next step is you have to FOIL this, just like multiplying two factors. Okay, let's see what do we get. Oh, when you write limit, especially showing works on exam, when you write an equal, always start with the limit. Don't just go ahead and do the algebra. I am sure your instructor will get super upset if you don't write the limit. Trust me. Remember, start with equal and limit. Okay, start with equal and limit. Okay, multiply. Root x times root x is x. And then you have a plus root x minus root x. So you have this. And then minus 1. And then the denominator, what do we have? The denominator, I don't think we need to multiply the denominator. Just leave it as x minus 1 times root x plus 1. So the top, the 2 root x got cancelled. No, always start with limit. If you just go ahead and do the algebra, your instructor will get super upset. Trust me. Every time I let my student do this, I will just say this out loud in class. Start a line with equal and limit. X minus 1, and then the square root of x plus 1, and then you have x minus 1. All right, get rid of this. Our biggest enemy is gone. Plug in. So you have 1 divided by root 1 plus 1, then that is a 1/2. So that is your final answer. All right, that is the end of this video. Remember, always write equal and then a limit. If you think that my instruction is helpful and clear, give me a like, share the video for me, click the subscribe button if you are on your way out. I will catch you all in the next video. Signing off for now.